Solve by the elimination method. Alright, so elimination method, the goal is to try to get opposite coefficients for one of the variables. So you select which one you want to work with. And it looks like if we were to select the x coordinates, it looks like we can get 10 and negative 10, which is already there. Looks like if we select the y coordinates, we can get 6 and negative 6 as opposites. Because 10 plus negative 10 is 0. 6 plus negative 6, it would be 12 and negative 12. So 12 and negative 12. You can turn the 6 into a positive 12 by multiplying by 2. So you have to decide which variable you want to eliminate first. So that would be your first step. Then the second step is actually multiplying one or sometimes both of the equations by some number. So I'm going to focus on eliminating the x's. So I'm going to multiply this first equation by 2. What that's going to give us is a 10x, and then plus 12x, and then equals 2 times 4 is 8. Don't forget to multiply that constant as well. And I'm just going to bring the second equation over. Alright, now what you're going to notice here is that you have 0 equals 0. Now, if this happens, it's a special case. If both variables are eliminated and you get a true statement, then that means there are infinitely many solutions. Alright, what does that mean? That means that if you were to graph these two lines, so we have 5x plus 6y equals 4. If you were to solve these for x, we actually have to do this anyway, so let me just show you. So bring down the 6y equals negative 5x plus 4. And if we were to divide through by 6, and I'm going to leave it like this, negative 5x plus 4 over 6. But for graphing purposes, you would write it as negative 5/6 x plus 4 over 6. This is not required in the problem, but I just want to show you what's going on here. So if you think about this, 4/6 is 2/3. So if this is 1 right here, it would be, the y-intercept would be about 2/3, and then it would be down 5 from there and right 6. So we would be somewhere way over here for our next point if we went down 5 and then right 6. So this would be down 5 and then right 6. If we graph this line, it would look like this. Again, elimination method does not require a graph, but I like to show you the link here. If you take the other equation, which is negative 12x, or negative 10x minus 12y equals negative 8, and you were to solve this for y, so plus 10x, negative 12y equals positive 10x minus 8, divide through by negative 12, you can separate this out. So we have 10 over negative 12x minus 8 over negative 12, which if you reduce this, it'll become negative 5 over 6x plus 4 over 6. And notice, they're the exact same equation. So when I say it has infinitely many solutions, if I were to graph the other equation, it would graph right over the top of this one. It's actually the same graph. All the solutions are every point on that graph. There's infinitely many of those. So what we do to write that, to write the solution for this, And let me just move this up here. So once we get the fact that there's infinitely many solutions, to write the solution set, it's a curly bracket, x, and then we want to write the y coordinate, but in terms of x. So it's this right here. That becomes our y coordinate. So this is why I told you before that we were going to have to solve this anyway. What that's saying is that pick a number for x, plug it into this equation, or it's actually an expression, plug it into the expression, negative 5x plus 4 over 6, to find the corresponding y coordinate. So that's how you write the answer for infinitely many solutions.